You ask an AI a question. It answers. Simple enough, right? But what happens when that answer, delivered with perfect confidence, is utterly, demonstrably wrong? This is the perplexing puzzle of AI hallucination. It's not a bug in the traditional sense, but a deep dive into the very nature of how these complex systems generate language and, seemingly, conjure facts from thin air. Imagine a perfect mimic, fluent and convincing, but with no inner understanding of the words it's repeating. This phenomenon reveals a fundamental characteristic of AI's current capabilities, a curious blend of linguistic prowess and factual unreliability that we must understand to navigate its outputs safely and effectively. It's a core aspect of how they operate, not an anomaly to be eradicated, and understanding it is key to our interaction with these potent tools. Headlines frequently shout about AI making things up or confabulating. Is this a simple glitch, a minor bug to be patched? Is it a sign that something is fundamentally broken within the algorithms that power these systems? Or is it, perhaps, something far more fundamental to the very way these machines are trained and process the vast, messy world of human information that we feed them? We are often told to trust these tools for information, summaries, and even creative sparks, yet they sometimes present fiction as fact, leaving us to wonder if we can truly rely on their pronouncements without careful, diligent verification. This isn't about a system that's accidentally misfiring. It's about a system that, by its very design and training methodology, can produce these outputs under specific, predictable conditions, making it essential to know why. The truth, as is often the case with advanced technology, is more nuanced and far more fascinating than simple error. These are not straightforward mistakes in the way a calculator might miss a decimal point or a database might return corrupted data. Instead, they are a curious, often unsettling, side effect of the very specific way that modern language models learn to speak, to mimic understanding, and to predict what comes next in a sequence of words. It's a consequence of their training on massive datasets, a byproduct of their underlying neural network architecture, and a direct window into their operational logic. We are witnessing not a failure, but an emergent behavior that is intrinsic to their current form, a direct result of the choices made in their construction. Imagine, for a moment, teaching a child to write and speak by showing them millions upon millions of books, articles, and conversations. They would learn grammar, sentence structure, tone, style, and the rhythm of language. They would become incredibly adept at stringing words together in ways that sound natural and persuasive, capable of writing essays or engaging in debates. But here's the crucial part. They wouldn't actually know or understand the facts contained within those texts in a human sense. They would be masters of linguistic form, of producing text that looks like understanding, but not necessarily of semantic truth or factual verification in the way a person does. This is the foundational concept for how large language models are trained, and it has profound implications. Large language models, or LLMs, operate on a strikingly similar principle, albeit at a colossal scale. They are fed enormous, almost unimaginable, oceans of text data scraped from the internet and digitized libraries. Their core task is to identify statistical relationships between words, phrases, and sentences. They learn, for instance, that the word dog is frequently followed by words like barks, tail, or fetch. They learn that sky often appears with blue or clouds. This probabilistic understanding of word co-occurrence, of how likely one word is to follow another in a given context, is the bedrock of their generative ability. They build a complex statistical map of language, a vast probabilistic network of how words connect. So, when you pose a question to an AI like ChatGPT or Bard, it's not performing a traditional search for a factual answer in a database. It's not consulting a knowledge graph of verified truths to retrieve a single, definitive piece of information. Instead, it's engaging in a highly sophisticated form of prediction. It generates the most probable sequence of words that would logically follow your prompt, based entirely on the patterns it absorbed during its massive training phase. It's essentially completing a sentence or a series of sentences that it has seen countless times in slightly different forms, optimizing for the most statistically likely continuation. This process is inherently predictive, not interrogative. Here's where hallucinations can arise. If, within its training data, a plausible-sounding, but factually incorrect narrative or statement is statistically more likely to follow your particular prompt than a dry, accurate, and verifiable statement, the AI will enthusiastically generate that more likely, but false, narrative. It has no inherent preference for truth. Its preference is for linguistic coherence and statistical probability. It selects the path that its algorithms deem most likely to occur based on its training, regardless of its grounding in objective reality. This is the core mechanism that can lead to invented facts, plausible but wrong, because the model prioritizes pattern completion over factual recall. Consider a simple query. The capital of Australia is. A well-trained model will overwhelmingly associate this phrase with the word Canberra, as that is the statistically dominant and correct answer found in its vast training data. However, the model also knows that Sydney and Melbourne are extremely prominent Australian cities and are frequently mentioned in contexts discussing Australian geography, history, or culture. These associations, though incorrect for the specific query about the capital, are very strong in its statistical model because they appear so often in the text it learned from, creating potential for confusion or invention. If the training data contains numerous plausible-sounding, but ultimately fabricated, accounts of, say, a minor historical event or a fictional scientific theory being presented as fact, the model might latch onto these as statistically probable continuations for related queries. It doesn't know it's fabricating. It's simply predicting the most likely linguistic pattern it has encountered. Think of it like a musician who has only ever heard jazz improvisation. When asked to play a melody, they might produce something that sounds beautiful and complex, but is entirely new and not based on any existing song. They are creating based on learned patterns, not recalling a specific composition. This is why LLMs can confidently assert incorrect information. The generated text is statistically the most likely continuation of your prompt, based on the patterns in the training data. If those patterns include plausible falsehoods or highly correlated but incorrect associations, the AI will generate them without hesitation. It possesses no internal fact-checker, no innate understanding of truth or falsehood. It is a supremely advanced pattern matching and text generation engine. Its confidence is merely a reflection of the statistical certainty of its prediction, not an indicator of actual knowledge. This phenomenon also explains why LLMs can be so creative. The same ability to predict statistically likely word sequences can be harnessed to generate novel stories, poems, or even code. By nudging the model slightly away from the most probable path, or by combining disparate concepts it has learned, it can produce outputs that are surprising and original. It's a tightrope walk between coherence and invention. The boundary between a hallucination and a creative leap is often incredibly thin, defined by the context and the user's expectation of factual accuracy versus imaginative output. Consider the implications for tasks requiring factual accuracy. When an LLM is used to summarize scientific papers, draft legal documents, or provide medical information, the risk of hallucination becomes a critical concern. A subtly incorrect fact, a misattributed quote, or a fabricated statistic can have serious consequences. This isn't a theoretical problem. It's a practical challenge that requires robust verification and human oversight. The tool is powerful, but its output must be treated as a draft, a starting point, never the final word on matters of truth. Researchers are actively working on mitigating these hallucinations. One approach involves reinforcement learning from human feedback, or RLHF. Here, human reviewers rate the AI's responses, guiding it towards more factual, helpful, and harmless outputs. Another strategy is to provide the AI with access to external knowledge bases or search engines, allowing it to cross-reference its generated text against verified sources. These methods aim to steer the model's predictions towards truth and away from plausible fabrication, essentially adding a layer of grounding to its linguistic fluency. However, these mitigation strategies are not perfect. The sheer scale of the training data means that subtle falsehoods can persist, and the probabilistic nature of LLMs means that even with safeguards, a hallucination can still occur. It's a continuous arms race between the model's inherent tendency to predict based on patterns and the efforts to constrain it to factual reality. This means that for the foreseeable future, human judgment and critical evaluation will remain indispensable when interacting with AI-generated content, especially in high-stakes domains. So, what does this tell us about the nature of AI? It shows that these systems, while incredibly powerful in their ability to process and generate language, do not understand in the human sense. They don't possess consciousness, beliefs, or intentions. They are sophisticated statistical machines, operating on correlations learned from vast amounts of data. The intelligence we perceive is an emergent property of these complex calculations, not a sign of human-like cognition or reasoning. Recognizing this distinction is crucial for setting realistic expectations and for developing appropriate safeguards. When an LLM generates a hallucination, it's not lying. It's not intentionally deceiving you. It is simply following its programming to predict the next most likely word based on the data it was trained on. If a plausible-sounding, but false, statement is statistically more probable than a difficult-to-access or less commonly phrased truth, the model will generate the falsehood. This is a critical distinction to grasp. It means we need to approach AI outputs with a healthy dose of skepticism, always verifying information that matters, rather than assuming accuracy simply because the AI sounds confident. The challenge lies in navigating the space between the AI's incredible utility and its inherent limitations. It can be an invaluable assistant for brainstorming, drafting, summarizing, and exploring complex topics. But its outputs, especially those touching on factual matters, must always be cross-referenced and validated. Think of it like a brilliant but sometimes forgetful research assistant. Their initial findings are useful, but you wouldn't submit a paper without double-checking their sources and facts yourself. This collaborative approach, leveraging AI's strengths while compensating for its weaknesses, is the path to effective and safe use. The future of AI development is deeply intertwined with solving this hallucination problem. Progress hinges on creating models that are not only fluent and creative, but also more reliably truthful and grounded in verifiable facts. This involves ongoing research into new training techniques, improved evaluation metrics, and more sophisticated methods for aligning AI behavior with human values and factual accuracy. The goal is to build systems that are not just powerful, but also trustworthy, capable of serving as reliable partners in our pursuit of knowledge and innovation. Understanding AI hallucinations is not just an academic exercise. It's a practical necessity for anyone interacting with AI today. It equips you with the critical thinking skills needed to discern plausible fiction from verifiable fact, empowering you to use these tools effectively and safely. It demystifies the technology, revealing it not as magic, but as a complex system governed by understandable principles. This knowledge is your best defense against misinformation and your key to unlocking the true potential of AI as a helpful tool. The next time an AI confidently presents you with a piece of information, pause. Consider the source of its knowledge, the statistical patterns in its vast training data. Ask yourself if this information is verifiable. Does it align with what you know to be true from reliable sources? This habit of critical inquiry is your essential filter. It transforms you from a passive recipient of AI output into an active, discerning user capable of harnessing the power of AI while mitigating its risks. It's about informed interaction, not blind acceptance. Ultimately, the phenomenon of AI hallucinations is a profound reminder that these are tools built by humans, reflecting the data we provide and the objectives we set. They are not oracles, nor are they sentient beings. They are sophisticated probabilistic engines. By understanding how they work, their strengths, and their inherent limitations, we can guide their development and deployment responsibly. This understanding is what allows us to build a future where AI serves humanity rather than misleading or undermining us. It's about wielding the tool with knowledge and intention, not awe or fear. The statistics behind these models, the data they learn from, the choices made by the engineers who built them, understanding that is what makes them useful, not scary. That deep dive into the statistical patterns took me a week of digging through research papers. A like and a subscription are why I'll keep digging into the next idea for Friday. The real race isn't just about who can build the biggest or fastest AI. It's about who can build the most useful, the most reliable, and the most aligned AI. It's a race to define the standards, the safety protocols, and the very philosophy of how artificial intelligence will integrate into our lives. The breakthroughs we see are built on countless choices made by real people with real consequences. And understanding those choices is the first step to navigating what comes next. Explaining the real stakes behind AI development takes time and digging into the mechanics. A like and a subscription are what make that deep dive possible. They fuel the next investigation.